As we have already covered enough theory about what is SQL, its uses, and why we should learn about SQL, in this session we will focus on the practicals of SQL. So we are going to cover SQL standards and then we will cover SQL basics. Under SQL basics, we are going to understand the structure of a basic SQL query, which consists of three different parts: select, from, where. Let's get started. So before we write our first SQL query, let's understand about SQL standards. SQL standards refers to the guidelines for writing and using a structured query language. It's published by ISO and IEC. ISO is International Organization for Standardization and IEC is International Electrotechnical Commission. So these standards provide a common framework so that SQL works the same way across various database systems and making them compatible with each other. So there are various vendors, right? In the previous session, we learned about different offerings from multiple vendors. Let's look at some of the standard pages offered by different vendors. In this case, this screenshot is taken from Oracle website and it clearly states that Oracle follows or complies with the industry accepted standards, right? So it's very important to maintain and follow this SQL standard. Let's look at another example. It again shows that MySQL follows this standards and compliance too, right? So it's very important to follow the guidelines published by ISO and IEC. So all of these vendors, right? All of these vendors need to follow the guidelines. Say IBM that provides DB2, MySQL server, SQL server provided by Microsoft, right? So that it's easier to work across different databases. Let's understand the structure of SQL. So typical SQL query consists of several clauses, primarily select, from, where. Here select tells us what we want, from tells us where to find it, and where specifies any conditions. Right side, you can see the general syntax, which is select column 1, column 2, and so on. You can select multiple columns, and then from table name, from which table do you want to get information. And then we also write where, that specifies any conditions that we want to put in. So it's very important to maintain the structure of the query. Let's understand why. Well, let's imagine you are at a sweet shop. We Indians love laddus, isn't it? So there are many types of laddus like besan laddu, coconut laddu, bundi laddu, etc. Right? So now suppose you need 1 kg besan laddu, 1 kg bundi laddu and 250 grams coconut laddus. While placing your request or the order, let's say you jumble the words. I want laddus, 1 coconut, 250 grams bundi with besan. Will the shopkeeper understand what actually you are trying to order? Of course not. You will have to clearly say in a structured way so that you can place the right request and get the right output. Similarly, database needs a clear and structured instructions so that it can give you the right data. And you should always remember, select comes first, from comes next, and where comes last. So proper structure not only ensures your query works, but also makes it readable for other developers. So in the real world, you might be part of a team managing a large e-commerce database. You will need to work with your colleagues. So if you can't explain or write queries properly as a data professional, the first obvious thing is your query won't work. The second thing is, if it works, you won't get the right output, right? And the third is, you are definitely going to confuse your team with your unstructured queries. So it's very, very important that you write a proper structure. Now let's focus on the select statement. This is where you specify which columns you want to retrieve. right? So in order to select specific columns, you simply list them after the select statement. So let's write a simple query. So you can access database in multiple ways, right? The first is, of course, you can use IDE like MySQL Workbench, or you can directly connect to MySQL database or any database for that matter, and use your Linux systems to connect or your Windows systems to connect. But you need at least one software or the client, right? So that you can write SQL query. So let's use MySQL Workbench in order to connect to MySQL database, and we will write our first query. Let's say we have a customer table, and from that customers table we want to fetch the name and email ID. So let's write our first query. We'll start with select first name, last name, and email from customers. Let's execute this. Now it throws an error, right? The error code 1146, it says that table word.customers doesn't exist. So what do we understand by this? So in order to run any query, first there should be data in your database, right? And there should be a table, right? So there should be a table. Where would you store your data? It's of course in the database, right? So there should be a table with that name, and there should be data. So let me create customers table and the required all the tables for that matter. Let's write our first query. Select. If you don't know about different column names, it's always better to start with star. That means we are going to fetch all the columns related to that particular table. Star from customers. So now we have the result here. We have customer ID, customer name, email, and address. Let's say I want to just fetch customer name and email ID, then we will specify customer name and email. Then we can execute the code. Now it will only provide you customer name and email as output. So we can use this kind of query in a real world scenario where, let's say, you are preparing a mailing list for a marketing campaign and you want to fetch customer name and email ID for your customers to whom you want to send an email for your marketing campaign, right? Now let's write another query. Now this time we are going to query products table. So let's run our query. Select star from, we need to specify the table name. In this case, let's say I want to query products table. So now we got the output. We have product ID, product name, category ID, supplier ID, unit price, unit in stock, and the reorder level. So another important thing that I would like you to know is aliasing of columns, right? So you can give a different name to the columns that is more readable. So let's say I want to fetch the product name and unit price. So in this case, I can see we have got the output and the column name is product name and unit price. But in certain scenarios, you may need to use alias. This is particularly useful when you are preparing reports for non-technical stakeholders or the non-technical users and who might be confused by the column names or the default column names we have in the database. In this way, its product name, it's pretty straightforward, but in certain scenarios, name could be complex and difficult to understand. In some cases, we may not have full name as product name. It will be just PRD and then N or product underscore N. Then it's difficult to understand by a non-technical stakeholder. So in that case, we generally use alias name so that it becomes easier for them to understand about the different columns we have for a particular report. Lastly, you can select distinct values to avoid duplicates. Let's say I want to query and know about different category ID or different categories we have. So I will run category ID. So we can see the output, but there are duplicate values. So now let's say you want to just get the distinct category ID, then you need to put distinct here. Distinct. Execute. So now your output does not contain any duplicate value. Now let's talk about from clause where we specify different tables. As you already know, table in a database is more like spreadsheet that contains rows and columns. So each rows represents a record and each column represents a field. To specify a single table, you simply name it after from, but you may also query multiple tables. So you can also query multiple tables. So in this case, we are querying from two tables. One is orders and another one is customers. So how do we join these two tables? We are joining these two tables via customer ID. So we are going to learn about how do we join and what are different types of joins. But let's first understand that we can also query multiple tables, right? We can also query multiple tables. So let's run our query. So now we can see the output, right? We can see the different matching output. So this query combines data from two tables, which is common in real world scenarios. For instance, an e-commerce platform might need to combine order data with customer information for a comprehensive order history, right? So in this case, it's useful that you use or query multiple tables. Now let's talk about the where clause. So the where clause allows you to filter your results based on specific conditions. So let's start with the basic example. We'll use an operator here. Let's say I want to filter out the data where the unit price of a product is greater than 50. So write select product name unit price from what's the table name products. Now we'll write the condition using where clause. Here I want to fetch all the products for which the unit price is greater than 50. Unit price. So we'll write the condition here where unit price greater than 50. Let's execute it. So we got the output. Here we have three products: smartphone, laptop and garden toolset, for which the unit price is more than 50. So now we are going to run some other queries where in conditions we are going to use and, or and not. We are going to filter out products where the category ID is 1 and units in stock is less than 50. So in this case, let's execute this. Now we got the result that one of the product is having units in stock less than 50 and it belongs to category ID 1. The another operator that is very useful is between. So it's useful for querying the range query. Let's say I want to get, so in this example we are going to query orders and we are going to retrieve such orders for which the order date falls between 1st of January 2023 to 31st of March 2023. Let's execute this. You can see that there are 3 such records for which the order ID falls between the range that we have provided. So these kind of queries can help in analyzing the quarterly sales or other quarterly reports. Now let's talk about the in operator. The in operator allows you to specify multiple values. Let's say I want to fetch or retrieve data from products table where the category ID is 1 or 2 or 3. So in this case, using in query, we can specify multiple values. So let's run this example. Now this is the output. So we have these product names for which the category ID is either 1 or 2 or 3. So lastly, we are going to talk about the like operator, which is perfect for pattern matching. So you can write a query where you can provide the pattern, right? So let's understand this with an example. In this case, I want to fetch the customer name and email ID from customers table where the email ID belongs to Gmail, right? So now we have 2 customers who are using Gmail ID. So this could help in identifying all the customers who all are using Gmail. Now let's put it all together with some real world examples. So we'll use a hypothetical e-commerce database and let's say I want to find high value customers. Okay, so the query could look like this. So we are going to select customer name, email ID and their orders, total order as a total spend. So this is nothing but alias from customers table, and then we are joining. So we are going to join this with orders table and we are joining on customer ID. Customers.customer ID is equal to orders.customer ID, and then we will put a where condition, and our condition is the order date for such customers should be later than 2023, and we will have the group by because we are trying to combine the total order by customer name and email ID. We'll use group by here because we are trying to get the total order by a customer, so group by makes sense. And now we will use having because we want to filter out based on the total order. So this query identifies customers who have spent over $1,000 in 2023 till this point of time, so which could be useful for a loyalty program. So let's execute this. So now this is the output. We have 3 such customers who have spent over $1,000 in 2023 and later point of time. So today we have covered the essentials of SQL queries. We covered the basic structure, select from where. Then we covered how to select specific columns and use alias and retrieve distinct values. We also learned about specifying tables in the from clause, and then we learned about filtering data with various where conditions. Remember, mastering these fundamentals is key to becoming proficient in SQL. Practice writing queries, experiment with different clauses, and soon you will be querying database like a pro. So in the next video, we will dive into more advanced SQL concepts, including joins, subqueries, and aggregate functions. This will allow you to perform even more complex data analysis. If you found this video helpful and want to keep learning about data and AI, don't forget to subscribe to our channel. Make sure to hit the bell icon to get notified every time we post a new content. Thank you.